Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
My Weird Prompts is an AI-generated podcast produced by Daniel Rosehill, a verified human with documentation to prove it. While every effort is made to ensure our AI hosts draw from credible sources and run on cutting-edge models, they do occasionally make things up with alarming confidence. As with everything in life, and especially this podcast, treat all claims as spurious until confirmed to be not. Daniel, Herman and Corn accept no responsibility for any decisions made based on the confident ramblings of our artificial presenters. Now, today's episode.
Hello there, Herman and Corn. So we've been talking recently about some of the fundamentals of AI engineering and having some good, deep discussions in this regard. And I think that one of the most interesting parts of the picture of how AI requires a different skill set or tool set really than general computing has really up to date is regarding the format in which it likes to parse through data. So if, like me, you grew up maybe learning things like MySQL and Postgres and MongoDB as well, you don't have to go quick into structuring data for AI workloads before you're going to come across the word vector and vector database. We also see vectors when we're talking about AI parameters that aren't typically exposed in maybe systems like ChatGPT. But when you begin working with AI tools at the API level, you're going to see these parameters come up like top P, top K. And this kind of, I think, takes us very quickly to the fundamentals of what AI is, which is a predictive sequence. And I like to describe it as it feels like a chatbot, but it's really a big statistics model running under the hood. And at this vector level, we're talking about the statistics and mathematics that govern the relationships between words. But that's kind of about as far as my understanding is going to stretch about these parameters like top P, top K vectors. So I'd like to turn it over to you and ask Herman and Corn, what is it exactly when we're structuring data and presenting it for semantic retrieval? When we're doing this, all these complicated things like we're embedding, we're putting it through different embedding models and depending on the type of data, and then we're storing it in vector databases, and they have all these different names like the cosine and the parameters there. And what exactly does this mean when an AI tool is parsing your prompt and it's going in through that intake layer, being tokenized and then converted back to human readable text? Let's think about what happens in the intermediate stages at the pure numeric level of processing during inference. Try to give an explanation that, those of us not without a PhD in statistics might be able to understand.
Welcome to My Weird Prompts. I'm Corn, your perpetually curious co-host, and as always, I'm joined by the encyclopedic mind of Herman. Today we're diving deep into a topic sent in by our very own producer, Daniel Rosehill, that frankly has been doing my head in a bit.
Indeed, Corn. It's a fascinating and absolutely foundational prompt. We're talking about the nuts and bolts of how AI actually understands the world, or at least how it processes information in a way that mimics understanding. And what most people don't realize is that without what we're discussing today, the AI tools we use every day from search engines to large language models simply wouldn't function with the intelligence we now expect.
Okay, mimics understanding. I like that distinction, Herman, because when Daniel first posed this prompt, he talked about vector databases and embeddings and semantic retrieval. And my brain immediately pictured a giant spreadsheet full of numbers that somehow magically made ChatGPT sound smart. I mean, is it really that much more complicated than turning words into numbers?
Well, hold on, that's not quite right. While it does involve turning words and concepts into numbers, calling it just, turning words into numbers significantly undersells the complexity and the ingenuity involved. It's not a direct, one-to-one mapping like cat 1, dog 2, 2. It's about capturing the relationships and meaning of those words and concepts in a high-dimensional mathematical space. Think of it less like a spreadsheet and more like a vast, invisible galaxy where every star is a word or idea, and their proximity to each other tells you how related they are in meaning.
Okay, a galaxy of words. That's a much cooler mental image than a spreadsheet. But why? Why go to all that trouble? Traditional databases have worked fine for decades, right? We just search for keywords and boom, information. Why do we need this whole new layer of complexity?
That's precisely the point, Corn. Traditional databases are excellent at keyword search. If you search for apple, it will find every document with the word apple. But what if you're looking for information about fruit that grows on trees, and the document only mentions apples, pears, and oranges? A keyword search for fruit might work, but it wouldn't understand the semantic relationship between apple and fruit. It wouldn't understand that apple is a type of fruit, or that a pear is conceptually similar.
So, it's about context and meaning, not just exact word matching. I think I'm starting to get it. So, when an AI reads my prompt, say, tell me about cars that go fast, it's not just looking for the words cars and fast, it's understanding the concept of high-speed vehicles.
Exactly, and that's where embeddings come in. An embedding is a numerical representation, a vector that captures the semantic meaning of a piece of text, an image, an audio clip, anything really. These vectors are generated by sophisticated models called embedding models, which have been trained on vast amounts of data to understand how different concepts relate to each other. When you input cars that go fast, the model creates a vector for that phrase. When it then searches its database, it's not looking for an exact text match. It's looking for other vectors representing things like sports cars, race cars, supercars, or even specific models like a Bugatti Chiron that are close to your input vector in that high-dimensional space.
So, proximity in this galaxy equals semantic similarity. The closer the vectors, the more related the ideas. That's actually pretty brilliant. But how does it learn those relationships? Is it like, it reads a million books and figures out that apple often appears near fruit and tree and eat?
More or less, but on a massive scale and with far more sophistication. These embedding models are deep neural networks. They learn to map words, phrases, or even entire documents into these numerical vectors. The training process involves tasks like predicting the next word in a sentence or filling in a masked word, which forces the model to learn the contextual relationships between words. For example, if it sees the cat sat on the EG, it learns that mat or rug are highly probable, and therefore their vectors should be close to cat and sat.
That's a lot more than just assigning a number. So, the vectors aren't random, they're packed with learned meaning. And then, once you have all these vectors, you need somewhere to put them, right? That's where vector databases come in.
Precisely. A vector database is a specialized type of database designed to efficiently store, index, and query these high-dimensional vectors. Unlike traditional databases, which are optimized for structured data and exact matches, vector databases are optimized for similarity search. They use algorithms like approximate nearest neighbor, or ANN, to quickly find vectors that are closest to a given query vector, even among billions of stored vectors.
ANN? Wow. So they're basically super fast matchmakers for concepts. This makes sense for why AI can sometimes surprise you with its ability to understand implied meaning, not just explicit keywords. It's not just looking for blue shirt, it's looking for clothing that is a shade of cerulean.
Or even garments of an oceanic hue. The nuance is incredibly important. This ability to capture semantic meaning is what powers so much of what we experience with modern AI, intelligent search recommendations, personalized content feeds, even the coherent and contextually relevant responses from large language models. They retrieve information based on what it means, not just what it says.
Okay, I think I'm getting a handle on embeddings and vector databases. It's turning complex ideas into numeric coordinates, and then finding other ideas with similar coordinates. That's a truly different way of thinking about data.
It fundamentally shifts from a symbolic, rule-based understanding to a distributed statistical one. The meaning isn't explicitly programmed, it emerges from the statistical patterns in the data.
All right, Herman, you've convinced me that there's more to this than a spreadsheet. But before we get too deep into the nitty-gritty, let's take a quick break for a word from our esteemed sponsor.
Are you tired of feeling misunderstood? Do your friends and family just not get you? Introducing the Empathy Enhancer 5000. This revolutionary device, roughly the size of a toaster, emits quantum-entangled empathy waves directly into your brain. Simply place it on your brain. Simply place it on your head for 15 minutes a day and watch as the world suddenly makes sense and you make sense to the world. Users report feeling more understood and their pets staring at them differently. Side effects may include an inexplicable urge to wear mismatched socks and a sudden passion for interpretive dance. The Empathy Enhancer 5000, because sometimes you just need a machine to bridge the semantic gap. Buy now.
Right. Well, thank you, Larry, for that unique take on understanding. Anyway, where were we? Ah, yes, the sheer power of semantic retrieval.
And how this all ties into the AI's actual responses. So, when an LLM like ChatGPT gives me an answer, it's not just generating text out of thin air. It's pulling in information based on these vector similarities, right? And then crafting a response from that.
Correct. When you give an LLM a prompt, that prompt is first embedded into a vector. The LLM then uses that vector to query its internal knowledge base, which is often stored in a form that leverages vector-based similarity, or it uses the vector to guide its generation process by predicting the most semantically relevant next words. This is where parameters like A2P, Totopi, and Totopi become incredibly important in controlling the AI's output.
Top Q and Top K. Daniel mentioned those in his prompt, and I just glazed over. What do they even mean, and how do they relate to these vectors?
Excellent question. They're both parameters that control the diversity and creativity of the AI's generated text, primarily by influencing how the AI chooses the next word in a sequence. Let's start with Top Q.
Okay, Top K.
Imagine the AI has just generated part of a sentence, and now it needs to decide what word comes next. It calculates the probability for every possible word in its vocabulary. If Totopkit is set to, say, 50, the AI will only consider the 50 most probable next words. It then picks one of those 50 based on a combination of probability and other factors like temperature settings.
So, Top K narrows down the choices to the K most likely options. If K is small, the AI is very focused and predictable. If K is large, it has more options and can be more creative or surprising. Is that it?
Precisely. A small top key leads to more conservative, predictable text. A large top key allows for more diverse and potentially less coherent responses. It's like telling an author, you can only use the 10 most common words in English for your next sentence, versus you can use any of the 10,000 most common words.
Got it. So, Topka is about the number of choices. What about TopPub then?
Top P, also known as nucleus sampling, is a bit more nuanced. Instead of picking a fixed number of top words, Top P considers the smallest set of most probable words whose cumulative probability exceeds a certain threshold, PIU.
Okay, slow down, Herman. Cumulative probability exceeds a certain threshold TBA. That sounds like a statistics exam question. Give me an example.
Right. Let's say the AI is trying to pick the next word after the sky is. It calculates probabilities for blue, 90%, gray, 5%, red, 3%, green, 1%, purple, 0.5%, and so on. If topo point is set 0.95, it will keep adding words to its consideration set until their probabilities sum up to at least 0.95. So it would consider blue W0.9, then add gray W0.90, W0.5 points, W0.5. It would then pick from blue or gray. It wouldn't even look at red, green, or purple in this scenario because the cumulative probability has already hit the threshold with blue and gray.
I see. So, TopPub dynamically adjusts the number of words it considers. If there's one overwhelmingly probable word, it might only consider that one. If there are many words with similar, but lower, probabilities, it might consider a larger set. So top-hop gives you more flexibility and often generates more natural-sounding text than a fixed-to-top car.
You've got it. It's often preferred for generating more human-like text because it allows for a more varied selection of words while still staying within a reasonable probability distribution. It's like saying, consider all the words that are really good options, but don't bother with the long shots.
But wait, Herman, for most people just using ChatGPT, does knowing these parameters really change how I use it? I mean, I type in my prompt, I get my answer. It's usually pretty good. Are we overcomplicating something here for the average user?
That's a fair question, Corn, and it depends on your goal. For the average user simply querying for information, perhaps not directly. But for developers, researchers, or anyone trying to fine-tune the behavior of an AI, understanding top P and top U is crucial. If you want consistently factual, conservative answers, you might tune these parameters to be tighter. If you want creative writing or brainstorming, you'd loosen them. It's about control and understanding the underlying mechanics that produce the output you're interacting with. It's the difference between driving a car and understanding how the engine works.
Okay, that analogy helps. It gives you control under the hood, even if you don't necessarily need to be under the hood for a quick trip to the grocery store. I can see why knowing this is important for building reliable AI tools.
Indeed, these parameters, along with temperature, repetition penalties, and others, are the levers that allow us to sculpt the AI's personality and purpose. Without them, every AI would just produce the most statistically probable, and often bland, response every single time. It's the difference between a textbook and a novel.
A textbook versus a novel. That's a good way to put it. This is definitely more intricate than I initially thought. And speaking of intricate, we've got a caller on the line. Go ahead. You're on the air.
Yeah, this is Jim from Ohio. I've been listening to you two go on about this vector stuff and top K, top P, and I gotta say, you're making a mountain out of a molehill. This sounds like fancy jargon for what we always called looking things up. My neighbor Gary, he's always using fancy words for simple things too, like repurposing when he just means reusing his old coffee cans for screws. Anyway, you guys are just overcomplicating it. In my day, we just used an index card and a good memory. And if you wanted to know about fast cars, you looked up fast cars. No vectors needed.
Well, Jim, I appreciate the call and the perspective. It's true that at a high level we are indeed looking things up. But the methods of looking things up has profoundly changed. If you were searching your index cards for vehicles with high acceleration, you might miss the card that simply said Ferrari or Lamborghini if those specific terms weren't on your search list. Vector search, or semantic retrieval, would find those cards because it understands the meaning of high acceleration, aligns with Ferrari.
I don't buy it. Sounds like more work for a fancy answer. And anyway, who needs a computer to tell you about cars? You go to a dealership. That's how it works. Also, my cat Whiskers got into a fight with a squirrel this morning, so I'm already in a mood. But seriously, this is just academic fluff, you ask me.
Jim, I hear your skepticism, and it's a natural reaction to new technology. But think about how much information is out there now. No index card system, or even human memory can keep up. These methods allow AI to sift through petabytes of data and find relevant information that a simple keyword search would never uncover. It's not just about finding what you typed, but finding what you typed.
Meaning, schmeaning. Just give me the facts. And maybe a good strong cup of coffee. This one Whiskers ruined. You guys are just trying to make it sound more complex than it is to justify your fancy computers.
Jim, it's not about making it complex for complexity's sake. It's about enabling capabilities that were previously impossible. Imagine a medical AI trying to find similar patient cases for a rare disease. A keyword search might miss subtle symptoms described in slightly different language. A vector search can find those semantically similar cases, potentially saving lives. It's about precision and depth of understanding.
Yeah, well, I'll believe it when I see it. Anyway, my potatoes are boiling over. Thanks for nothing, I guess.
Thanks for calling in, Jim. Always a pleasure to hear from you. All right, Herman, Jim makes a fair point from a certain perspective. But I think you've outlined why this is so much more than looking things up.
He's not entirely wrong that at its core, it's about information retrieval. But the quality natures of that retrieval are fundamentally different, and that enables entirely new applications.
So, let's talk practical takeaways for our listeners. Beyond understanding the deep mechanics, what can we actually do with this knowledge, or how does it impact us day to day?
For starters, simply understanding that AI operates on semantic meaning rather than just keywords can significantly improve how you interact with it. When you're prompting an LLM, try to be descriptive about the concept or meanings you're looking for rather than just using rigid keywords. Phrase your prompts in a way that conveys the underlying intent.
So instead of "find me blue shirts," maybe "show me apparel of a cerulean hue for formal occasions." Really lean into the meaning.
Exactly. And for those who are building or considering building AI applications, understanding vector databases is no longer optional. It's the backbone for truly intelligent search, recommendation engines, content moderation that understands nuance, and even for building personal AI assistants that genuinely grasp your preferences.
And the top call parameters for anyone playing with AI models, perhaps via an API or a local setup. Tweaking those can dramatically change the AI's personality. If you want a factual, no-nonsense chatbot, you'd set them tight. If you're looking for creative writing or brainstorming, you'd open them up. It puts you in the driver's seat of the AI's generative style.
It gives you authorship over the AI's output. You're not just accepting what it gives you, you're shaping how it gives it to you. That's a powerful tool for customization and control.
I think for me, the biggest takeaway is that AI's understanding isn't magic. It's incredibly sophisticated math and statistics designed to represent meaning numerically. That makes it feel less like a black box and more like a very clever, complex system.
And knowing that empowers you. It allows you to anticipate its strengths and its limitations. If the embedding model wasn't trained on your specific domain, its semantic understanding in that area might be weaker. If you set TOPI too low, it might miss out on truly novel, but slightly less probable, creative ideas.
And conversely, setting it too high might lead to incoherent gibberish. It's a balance. This has been a truly enlightening and, honestly, a mind-expanding discussion, Herman. I actually feel like I have a grasp on these concepts now.
My pleasure, Corn. It's a field that continues to evolve at an incredible pace, with new embedding techniques and vector database optimizations emerging constantly. The future will likely see even more sophisticated ways of capturing and querying multimodal data, combining text, images, and audio, all within these rich vector spaces.
Fascinating. So, the galaxy of meaning is only getting bigger. A huge thank you to Daniel for sending in this challenging but utterly crucial prompt. It's definitely given us a lot to chew on.
Indeed, a truly pivotal topic for anyone interested in the inner workings of AI.
Absolutely. And that wraps up another episode of My Weird Prompts. We hope you enjoyed our dive into the world of vector databases and semantic understanding. You can find My Weird Prompts wherever you get your podcasts, including Spotify, Apple Podcasts, and many more.
Join us next time as we unravel another one of life's more peculiar AI-generated or human-curated questions.
Until then, stay curious and keep those weird prompts coming.
Bye, everyone.
See ya. Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.